Right, bearing. So first of all, what is bearing? Okay, bearing is just a clockwise angular relationship between two distant places. Okay, normally we could measure the distance between two places. Okay, we could describe the relationship between 2 points, maybe a house in a particular place, another house in maybe a far away distance. Okay, we could describe some relationship between them. The first relationship we could quickly describe if we are looking at those houses from the top. Okay, you're looking at it from the top, maybe aerially. Aerially means you are looking at it from the top. So say you take a drone and then you launch the drone into the air. So the drone will be seeing all the buildings, the top of the buildings from the top. So if I want to pick the relationship between two houses by looking at them from the top, the first thing I'm going to check out is their distances apart. Okay, I could describe them based on the distances that house A is about a particular distance to house B. Okay, well, instead of just only distances, we could use other things like degrees to measure them. Okay, like so say if you're trying to measure from using your protractor, for example. I'll show protractor in this video. I'm going to show protractor how to use them. So you could use protractor to measure them between the houses, but you could say, oh, the protractor is quite too small for such real distance because the house is bigger than the protractor you want to use. But most of these things we're talking about, they are just like maps on a piece of paper. So if you really want to measure anything on a piece of paper, you use mathematical tools, which are the protractor, any other thing else. So in a protractor, we see degrees, we see angles, okay, be written on them, whereby it can be used to measure the degrees from one house to the other based on their distances apart. Okay, once the distance apart has been drawn, then we can calculate the degrees at which the first house, okay, from its true north all the way to the line drawn from house A to house B. The true north, which is the northern part, okay, because every point on the earth surface has its own 4 cardinal points. So from its true north, or you could say from 0 degree of the north is 0 degree, all the way down to the line that joins the two houses together. So it's basically just another way of describing distance places. But one other thing to take note of is that it is measured in degrees from the north. Okay, this north that we have here is super important. Okay, that north there is very important. This offering here is very important. That's why I had to underline it. And then clockwise is also very important because you don't read bearing as if you're going backwards. Nope, you read bearing just like you're going forward. It's like a clock direction. That's the meaning of clockwise. The movement of the hand of the clock, the second hand or every other hand in a clock is to move in this direction to the right. Okay? To the right, not to the left. So this is clockwise direction. So these two guys are very important, north and clockwise. They are very, very important. Okay, so I can move on to the second bulletin. It said the relevant directions and bearings are the north, okay, the south, the east, the west. These 4 guys are the first thing if we actually want to draw bearings. In mathematics, if you want to draw bearings, want to describe places, distance, places, okay, and we want to use a bearing to do that. we start with the four cardinal points, which we are all very familiar with, by drawing four lines, one line vertical, one line horizontal. The top here is the north, the side here is the east. Sorry about that. Side here is the east. Okay. Side here is the west, and the side here is the south. Okay, I'm going to show you what I'm talking about in a moment. So this is the north, east, southwest. So if I say this side here is one position, maybe house A, this is where house A is right here, and maybe house B is maybe somewhere here. Then I want to describe house A to house B. I'll probably use distance first. So if I use distance, let me quickly make something here. If I use distance, that means I'm going to draw a straight line to point B right there. Right? Straight to point B, but I'm not going to use an arrow in this case. Okay? Just make use of a line. So I'm going to draw straight line. So this is right here, point B. This place is point A, but talking about this place is point A. But what I'm going to do is I'm not going to write point A right here. I'm just going to write it outside of here. So this is our point A, and this place is going to be the point B, the other house. So every point has its own four cardinal points. Now this point B will also have its own four cardinal points, having north, east, west, and south. Okay, so now this line that is being drawn here from here to here, that line is in distance, maybe about 50 kilometer. Remember, this is point B. Maybe the house is about, let's say, 50 kilometers away, 30 kilometers away. I don't know, but just an assumption. So, and I want to measure the degrees of between the two of them. Maybe I want to measure it from point A. Then I can draw from the north of A all the way down to the line that joins the point A and B. Then I can use my compass to measure the bearing. Then I write whatever the bearing is. Maybe the bearing is about, let's say, 120 onto 0 degrees. Yeah. Okay. So this is just a sketch of what we are about to embark on, but let me go back a little bit to basics. Okay. Sorry, I'm coming a little bit. So let me go back to the basic moment. All right. So, like I said, bearing a clockwise angular relationship between two places, measures in degrees from north relevant directions, bearing are the north, south, east, and the west, which I've shown you from the little illustration I've just done with my hands right there. So let me move on. Now, like I said, when we want to draw bearings, first we start with the four cardinal points, which is the number one thing is the vertical line, followed by the horizontal line, and then we can place our north, our south, east, and the west. Right. So let me take it back a little bit. Now, I'll say it again. We start with a vertical line and an horizontal line. Then we go with the north, the south, the east, and the west. Now, like I mentioned, a compass. The protractor, it doesn't end at 180 degree. Maybe the one you're familiar with is 180 degree. Although I'm going to be using the 180 degree a lot in this video. That's what I'll be using. But the first one I'm going to introduce in this first short short is the 360-degree protractor, which is something that looks like this. As you can see on that protractor, we have we have here 360-degree, but in actual sense this is 0 degree. Not is always 0 degree. Take it back. 0 degrees. This is 0 right here. Then all the way down, it moves 0, 10, 20, 30, 40, 50, now 180 degree, 270, then 360. Okay, so what does that mean? It means the first thing here is 0. At this horizontal line to the east is 90 degrees. At this place at the south is 180. Please don't mind my drawings. Just try to look interactive. Then on this side is 270 degrees. And then when you come back to the top, you get 360 degree again. Yeah. Okay. 3 is 3, 6, and 0. I mean, right here, that's where the 360 degree is. It's like so if you move from 0, which is not degree, which is the not 0 degree, to the east 90 degree, and then to the south 180 degree, then to the west 270 degree, and then back again to the north, which is 360 degree. You can pause the video, check the compass, check the lines, check everything, and then come back. So let me move on to the next aspect, right? Right, so move on to the next one now. Well, in bearing, this is mathematics actually, so you need to be able to represent bearing by yourself, because where I'm taking this video to is where you use bearings to do some simple mathematical calculations, okay, under the applications of bearing. Now, representation of how do you represent bearings? Just say, for example, I give you some questions like this, and I said, represent the following bearings on simple diagrams. Okay, on simple diagrams. Remember, I said if you want to represent a bearing like this 20 degree, the first thing is, since it is a bearing and you're trying to represent it, okay, on a diagram, so this is 20 degree, then the first thing is you indicate the vertical line and the horizontal line, right? The north, the south, the east, and the west. Then you label your 20 degree. Now see what we have. So 20 degree, that's what we're starting with. So the vertical line, the north, the south, the horizontal line, the east, and the west. Now, since this is 20 degree, it's going to start from the north, which is 0 degree. Now, pick up your protractor. Now you can see my protractor of 180 degree. You can see the way I placed it. Let me remove that. Go again. I placed it on the vertical line. Okay. I placed it on the vertical line. Okay. I can't place it on the horizontal line because that would be difficult for me to read 20 degrees. But to make it easier to read the 20 degrees, you can see this is 0 right here. Well, I said you have to start from north. This is 0 right here. And I said you have to start from north. So that means you have to turn your protractor a little bit, okay, so that it touches the vertical line, this vertical line. Okay, so once you touch that and then you place the midpoint of your protractor at the midpoint between the horizontal, the point of intersection between the horizontal and vertical line. So then you measure 20 degree with your protractor and you pinpoint that 20 degree. After that, then you draw a straight line to that point of intersection. So all you're saying in essence is that everything in this place from here to here, okay, here to here is 20 degrees. All right, so let me show you what I'm talking about. Now this is what I'm talking about. Let me remove the protractor and I bring it back again. Place it on it. Now I've read it from north, which is 0 degree, all the way to 20 degrees. So I'm going to place it right there. You see 20 degrees. So then after I'm done, not actually drawing the line, but making a point at this junction here. You just use your pencil or whatever you're using to draw it, use to make a point here. Then you remove the protractor. Then you draw a straight line up to this point. Okay? Just because this is a digital representation, that is why it might look a little bit different, but the same process. Just make sure you pinpoint the 20 degree, then you let go. So this is what we're talking about. So remove it, put it back, 20 degrees. Now take it off. Then you have your degree lines, the curve lines. That place is 20 degrees. That is just the way to represent 20 degree bearing. But in some cases, when you don't have a protractor, let's say for instance, we get to the calculation aspect where we don't need protractor to calculate bearings. Okay, in that aspect, it could be sketched. For instance, if I draw a straight line, please don't mind my drawings coming in a moment. Let's say you want to draw a straight line, bring it here. Draw a straight line here, right? Then draw another one. Then you call the top north, this place north, this place east. Okay. Then you call this place south, west, which is exactly the way they used to be. Now, if you want to measure 20 degrees, you can't call this 20 degrees because you can't tell me this place here is 20 degrees. That is a bit too much. As you can see in the diagram here, 20 degrees is not that long. So if I just want to sketch it, just want to sketch the bearing, all I have to do, just sketching it, all I have to do is to just make sure, because normally I can use my eyes to draw a line to divide north and east. Now, since north is 0 degree and east is 90 degrees, so the distance, the bearing between the both of them is 90 degrees. So their midpoint will be 45 degrees. This place will be 45, this place will also be 45. So it means if I want to draw 20 degrees, it would be too much. Okay, I can say this is 20 degree. Okay, remember I call this half of it. I can just call this 20 degree and then label it 20 degree. Let me remove the other part. Okay, I can call this 20 degree and label it 20 degree, which is quite nice. Good. The reason why I'm trying to lay emphasis on this, if you have to sketch it, is because by the time you want to use it to do some simple calculations, you're going to have to draw the diagrams pretty well. If you're not using, protractors, you're going to have to draw it pretty well. Okay? But if you're going to use protractor, then definitely it's going to look exactly the way it's meant to look. All right. So let me move on. So this is for 20 degrees. So let me take it to the next one, which is 120 degrees. As you can see, the vertical line, north south is west, then the protractor at 120 degrees. And you can see the line for 120 degrees. You can see where it's facing. It's different from the 20 degrees that is like this. Okay. So it's 120 degrees, which is passing this east, past the east, because the east is 90 degree. So if it's 120 degree bearing I'm drawing, then it has to move from 0 all the way to 90 and then to pass 90 a little bit. So 120 degree. Okay. So let me go again. So let me go again. So protractor, the 120 degree measured. And remember, if you are measuring the 120 degrees, we're not using this red line of the protractor, because that was here. It starts from 180 degrees. This is zone 0, but we are calling our knot 0. So we're calling the knot to be 0. So you have to start with the other one that starts with 0 on the protractor. Okay. So the next is to draw the curve that indicates the bearing. Okay. Move it, draw the curve, indicate the bearing, and we call that 120 degrees. It doesn't mean that the 120 degrees that we have there is only for this part here. Nope, it is actually all this part up to this line here. That's 120 degrees. It's 0 degree, 0 from here, and then move on to 10, 20, all those numbers. We go to 90, then 90, as you can see from the protractor itself, 90, 100, 10, 120. So that's just the way it is. All right, so we're gonna move to 330 degrees. 330 degrees. All right, straight to 330 degree. To draw the bearing for 330 degree, that is quite easy based on what we've done previously, which is the 20 degree and the 120 degree. So if we are drawing the bearing of 330 degree, let me first sketch it before I bring in the animated stuff. Okay. So if I'm going to draw 330 degree, the first thing, as usual, is our straight line first. Okay. The straight line first. First draw straight line. That's the straight vertical line. Then we'll move on to draw the horizontal line. Then we label it up as not this side here as the east, side here is the south, and this other side here is the west. Okay. And then we pick up the compass to read 330 degree. Now, one thing I want you to be very careful about is that so far you know that north is now 0 degree. Okay. 0 degrees. And east is about 90 degrees. Not about, it's just 90 degrees. Okay. And this part here is 90. Okay. You could call it the angle between north and east is 90 degrees. As well, the angle between south and east is also 90 degrees. And the angle between south and west is also 90 degrees. And also this part 2 is 90 degrees. Okay, that is very, very important. Okay, so if this is 0 and this is going to be 90, if we add another 90, we're gonna have 180 degree here. Okay, and if we add another 90 to 180, okay, we're gonna have something else there at the west. So here is going to be 270. Please don't mind my drawings. I'm trying to label it correctly. It's going to be 270. Then if we go back to the knots. Then we're gonna have something else. We're gonna have now 360 to 360 degrees. I hope that is clear, please. Okay, they're not together, separate. So 360 degrees or 0 degrees, that's our knot. So if I'm going to label 330 degrees, 330 degrees will as well start from the knot, which is 0 degrees. And then I'm going to move all the way. Normally I'm going to use my compass and my protractor, but if I have to sketch it, okay, I'm going to move 0 degree to here, 90 degrees. So this place 180 degrees, and then 270 degrees. Remember, I'm going to 330 degrees. So 330 degrees is actually more than 270. So if 330 is more than 270, that means we're still going to continue to move our indicators. Our indicator, which indicates the 330 degree. Okay, so the indicator continues all the way to this 270. So at least this will be 280, 290, 300, 310, 320, 330, somewhere there. So if you've labeled it 330 and then you can just slash it a little bit, and bam, that's 330 degrees. Okay, that's just the sketch. But let me bring in the animation so we'll see what we're talking about in a moment. Okay. Hold on, please. I'm trying to get all of this one. Now, to take it back using this, okay, the first is the vertical line, followed by the north, south, you write the north, the south, and then the horizontal line, and then you introduce the east and the west. Then you bring in compass. Now, because we are making use of 180 degrees and protractor, not a compass, sorry, I mixed the two of them together. So if we are going to be making use of a protractor 180 degree, the way we're going to place the protractor on this diagram is going to be a little bit different compared to what we've been doing so far. When I started the 0 degree and 120 degrees, I didn't change the direction of the compass, but in this case, I'm going to change it because I'm going to 330 and the protractor, rather, the protractor is not a 360 degree. I can bring the 360 degree round protractor into this, but in most cases, what is readily available is the 180 degrees protractor. So now you can see this is the 180 degrees protractor. So if I had to measure 330 degrees, I know already that this north side is 0 degrees. This place is 90 degrees. This place is 180 degrees. And I'm going to 330. So, and also this west, due west or westward is 270 degrees. So that means I need to add more to that 270 degrees so I can get to 330 degrees. So if I had to add more, if this is 270, then write it out, 270, okay? 270. So this is 270, and you can see this is 270, represented, 90 is represented to 270 around that side. That is 270, then this place is going to be 280, that's plus 10. Okay, this place is going to be 290. Okay, remember 270, 280, 290, 300, 310, 320, 330. This is where our 330 lies. Okay, it's not that 150 is 330, but 150 is just the way the protractor has been graduated. This is the way it is. we are using half of the protractor, but if we're using the full protractor, that will be a different case. We could just get 330 directly, but we're using half of it, which is the reason why I'm using it is because this is what's already available out there. Okay, so this part here now is 330, and I've drawn a straight line down to the point of intersection between the horizontal and vertical line. Then for me to use that curved line, which is the indicator, to show that, okay, this is my 330-degree bearing. So the indicator moving all the way here. Then you can write it this 330 degree, or just leave it. Okay, this 330 degrees. Now let me show you what I'm talking about. Right, so wait. Sorry. Okay. All right, so protractor. Now that's 330 degrees. Quite simple. And then move your protractor, and then your indicator. Okay. That is the way it is for 330 degrees. It's quite simple. Okay. So if I want to make just some simple example for, to say, okay, I'm just indicating that 300 degree right there. Now, if I want to do some simple example, let's say I want to make, you can't make anything other than 0 to 360. You can't make 540 because a circle, the angle in a circle is 360 degrees. So you can't fish out 540 degrees from a circle. It will only go from 0 degrees to 360 degrees. Okay, hope that's clear. So if I want to make, say I want to make 230 degree angle. Okay, 230 degree angle. Let me write it here. 230 degree. So number one is to first draw the vertical line. And secondly, I'm going to draw a horizontal line. Then I'm going to have to label it. Okay, I have to label it. So I have to label this part north. Let's label this part east. This part will be south. This part will be west. Right. So, and then the next part is to bring in my protractor, but I can't bring in the protractor because this is just a sketch. I'm just trying to sketch it. Okay, if I have to sketch it. So 230 right here at the north side, I have 0 degrees. We have what you call 360, not 350, /0. It's either 360 or 0 degree. Right here at the east, have it to be 90 degrees. And we usually call this top here northward. Okay, or we can call it due north. Okay, because this is directly north. That's the meaning of the northward or due north. Then right here we call it eastward, or we call it due east. Okay, and at the bottom here we call it southward, or due south. And then right here, call this right here westward, or due west. Okay, and here is 90 degrees, as you can see, while this part is 180 degrees. And this other side here, which is the west, is to 70 degrees. This is 360. This is basically how it is. And all of this internal parts here, they are all 90 degrees, 90 degrees, 90 degrees, 90 degrees. Okay, so that's what it is. So I want to make 230 degrees. So if I want to make 230 degrees, 230 degrees is going to be much more longer than 180 degrees. Going to pass it by, but it is never going to pass 270. Okay, so if I want to draw 230 degrees, so I can make 230 degrees to be probably if this is 180, then we can have 180, and you can even pinpoint the midpoint between 270 and 180. Okay, if I have to calculate the midpoint between 270 and 180, okay, to do that, you just add 270 to 180 degrees and you divide it by 2. Okay, so if we had 270 degrees plus 280 degrees, we're going to arrive. So if we add it together like this, I mean, find the average, the midpoint between 270 and 280. Okay, sorry about my drawing, please. So if we have to do that, return back that 270, please. 270. So if we are going to add them together, that means 270 plus 180 divided by 2, that is 225. Okay, 270, 180 divided by 225. That will give us half of it. So half of the 2 guys is 225. This half right here is 2 to 5. Okay, their midpoint is 2 to 5. So if this place is 2 to 5, and then you go into 230, 230 will just be very close to 2 to 5. That's if we have to sketch it. This guy here will be around 230. It can represent the 230. So we can just so this will be 230 right here. We remove the 2 to 5. But we need just the 230. So that's the 230. Then bring in the indicator to indicate we have. So indicate this. So all you just drawn so far is 230 degrees. It's quite simple.